So this is the last section in chapter 6, and we're going to do the analysis of machines. Machines are a lot like frames, but they are essentially going to take motion and force and translate it into something else. And we'll take a look at each example of machine, and hopefully that will make this more clear. But the solution process is going to be exactly like it was for frames. So first step we're going to do is we're going to disassemble the machine. Second part is free body diagrams of each part. And we're going to keep in mind Newton's third when we draw those. To help us get the directions properly. Then once you've drawn those, you can apply equilibrium. So some forces equals 0, some moments equals 0, and that'll get you to the solution. Solutions in this case will typically be something like I'm applying a force in one place, how much force is applied in a second place. That's the nature of machines. The goal of a machine is to take a force applied in one direction or in one method like rotation or something like that, and turn it into another thing such as a straight line force. All right, so let's look at a classic machine example, a pair of pliers. All right, so here's our pair of pliers, and this is a pair of wire cutters, right? So you would apply a force here, and then if there's something in the jaw, it would cut this. This would move this way, and this would move that way, and you would cut through. So basically, you're taking the force of your hand and converting it to force at the cutting face of these of the jaws there on the pliers. So we'll do exactly what we said we're going to do. We will take this and disassemble it. So there's one half, and here is the other half. Oops. Right, and there's effectively a pin joint right there, so you can see this thing. There's a joint right there that allows these two sides to rotate inward, and so that's the joint right there. And you would apply a force here. That would be equal and opposite to the force that you applied using your hand. There would be some sort of reaction at the pin joint, right? Notice again I'm using Newton's third law. And then there's some resistance force due to whatever's in the jaw. So if there was a cable here, you draw the free body diagram of the cable where the force of the cutting jaws are being applied on either side of the cable, ideally to cut it. And then the equal and opposite force is being applied on the jaws, right? So to cut something, obviously, your jaws have to be stronger in some sense than what you're trying to cut through to do this. All right, so again, right, this looks exactly like the frame. You took it apart, you drew the free body diagram. There is, keeping in mind Newton's third law, equal and opposite for both sides. You would then go ahead and some moments, probably around A, and then that would get you the R. So assuming you know if F is known. All right. So that's in some sense that's the practical solution, right? You want to know if I put 50 pounds on here, is this going to be enough to cut through the cable here? Assuming I have that information, let's say 200 pounds is required to cut through the cable or something of that nature. So then you could easily, given the dimensions here, L, and the distance to the cutting face, B perhaps, then you could actually go ahead and calculate the moments and then figure it out, and that would be how it would go. Then you could also then from there do some forces to find the reactions at the pin if that was particularly of interest. So again, that's pretty much it. This solution technique for frames is you've got the body, machines, you've got this body, you take it apart, draw the free body diagrams of all the constituent pieces, and then from there apply your equilibrium, some forces and some moments all equal to 0 to get to the answer. And that's pretty much it.